Hi, my name is Lance Brewington. I'm an NRCS soil scientist. I graduated from Clemson and have been a soil scientist for 19 years now. Started out in Bamberg, South Carolina in the coastal plains and have been in the Piedmont for 18 years. And today in this video we're going to talk about what is soil. So just to give you a little background, the dirt on soil, here's some popular people through human history, and you can read their quotes, but the main thing is you don't have to be an artist or a president of the United States or anybody like that to realize the importance of soils. And here's just some examples right here in this slide of how soils affect your everyday life. Of course, food grows from the soils. Everybody eats food. You got water. Water is cleansed through the soil. The clothes you wear, believe it or not, are directly tied to the soil, because one main plant I think of right off the bat is cotton. A lot of your clothes, if you look inside the tag or on the tag, it says 100% cotton or some percentage of cotton in that clothing. The building we're filming in right now is sitting on soil, or all buildings sit on soil, so you depend on that for engineering purposes. The air you breathe partially comes from the plants that are grown in the soil, and nearly all antibiotics are from soil also. Basically, without soils, life would not exist as we know it. That's a pretty powerful statement when you think about it. If you just take the time to think about it, life would not exist as we know it. And just as a side note, 1 billion of bacteria, a teaspoon of healthy soil contains up to 1 billion bacteria in more than 4,000 species. That's just a side note. But the main thing I want you to get from this slide is that right there. Life would not exist as we know it. Okay, what is soil? This definition here, natural body on the Earth's surface, is three-dimensional. Another main thing is its boundaries are air, rock, and water. Right here, you can pretty much see water is one main boundary. What's beneath your feet and up to where you're standing is air. And then you have rock as a boundary. So you have water, you have the air because there's no soil in air, and then you have rock, which is a hard bedrock, which is its other boundary. Just kind of read this right here. It's a body composed of mineral, organic material, gases, liquids, and living organisms. So you're probably thinking right now, gases and liquids, how in the world does that tie into soils? That's what a lot of people think. They think gases and liquids. So I'm getting ready to show you how that ties in, but it's a very important part. Okay, the ideal soil: air, water, 25 and 25, mineral matter, and then you got the organic matter, 5%. Well, 5% is a good thing, but that's a good number to get to. But in our area, we typically have 1% due to past farming practices. But this air and water, see this right here, this is found in your pore space, which is around the mineral material and organic matter. So that pore space, plants have to have pore space to survive, and that's why the air and water is so important to the soil. Soil is not dirt. I hear that, oh, you're a dirt doctor. You're talking about dirt. No, I'm talking about soil. Dirt is basically is defined as soil out of place or out of its natural environment. One example of dirt is what you drag into the house on the bottom of your feet after a rainstorm. That's dirt. Soil is a medium for plant growth. Very important definition. It's a recycling system for nutrients. It's a system for water supply and purification. One example of the purification of water is in wetland areas. When you see that water sitting out in a wetland area or a boggy area, just think about it. That water is being purified so that it can move on through the system. And it's also an engineering medium. Big time engineering. Any city you drive by, that soil is looked at as an engineering medium. They want to know, will it hold or sustain a building? What can I build on it? An engineer would say that. What can I build on it? And it's also a habitat for soil organisms. The main one that most people think about is just the earthworm, because that's one you're more likely to see. Soils also perform vital functions. Okay, as we've already said, they sustain plant life. You have rainwater that falls, it either goes into the soil or you have runoff into your streams and rivers. And everybody that's been in the Piedmont can see after a good rainstorm, you see that red color in your rivers, that's from runoff. That's telling me there's somewhere that soil is washing away. You also have filtering. For example, that'd be a wetland area, and also providing support for structures, which the building we're in today is heavily dependent on the soil to hold it up. Soil is the basis of the ecosystem. You don't ever think about that. Most people just walk across it and they don't give it a second thought. They just walk right by it and don't even look at it. But if you dig a little deeper, you begin to see that soil is actually living. It's a living, breathing entity, basically, because you got, you know, microorganisms all the way up to earthworms that are in the soil, moving, living, carrying out their day-to-day processes. Soils support life. That's a very powerful statement there. They support our life. Some of the organisms they support are bacteria, fungi, earthworms. The roles of some of these things are decomposition. They create pores in the soil, which are for air and water. So the soil is basically alive. You don't think about it, but you need to stop and think about it because it is alive. Okay, with this video, we're kind of going to use an apple as our example, and we're going to remove pieces of that apple to show how much soil we actually have to farm and actually we live off of. So you start with the whole apple, which is our earth. There's 75% of the earth is covered by water. Well, that's one of the boundaries, so you can't farm that. Okay, 50% of the dry land that's left is either desert, mountainous. You have mountainous regions. It's too hot to be productive, so you're only left with 12.5%. So you see, we're getting kind of thin here. Of that 12.5%, 40% is too rocky. It's too steep, too shallow. You know, it just doesn't support food production. So you're only left with 10% of that apple. So you peel the skin from that tiny remaining sliver, and that's what we have to live on. That's our world's food supply. In the world, the population is continually growing. So we got to be mindful of the way we're using our resources because you're not making any more. Okay, now we're going to switch gears a little bit and talk about soil classification and mapping, which is kind of where I come into looking at how I look at soils across the landscape and how I group these soils. Okay, I'm looking at physical, chemical, and biological properties that's important to their use. Color being very important. If it's red versus brown versus gray or anything in between. You got structure, texture, consistency, the amount of roots, lack of roots, you know, pores. And there's those composition again, solids, liquids, and gases, and their ability to support rooted plants. So there's that term, liquids and gases again, which that's in the pore space. Soils are formed through a series of processes called soil forming factors. The soil forming factors are parent material, which is the type of rock it formed from. Climate, what kind of climate do you have? You have 40 inches of rain a year versus 5 inches of rain a year. The living organisms you have, how many and what type? The topography, are you in the mountains or are you in the floodplain or on the coast? And the time, how long did it take to form that soil? I mean, is it a fairly young soil, which would be in a floodplain, versus an old soil, which is an upland soil? And then we kind of group these things, and we got a book that we call a soil survey. And it's an inventory of the soil across that landscape. It's got maps in it, you got descriptions, you got properties, you got the climate of that area or that county. And this is an excellent source of information. You know, about 97% of all the counties in the U.S. have a soil survey. All of the counties in South Carolina have a soil survey. So we've already mapped South Carolina, and this information is available online or in a hard copy format. Soils have limitations that can endanger human health and safety. We have 3 highlighted right here in yellow, and the 3 examples of each one of these highlighted. So you have septic failure, which is shown in the middle slide. If you've ever driven by a house or a road cut and you see gray water looks like coming out of the road cut, or in the yard you see a puddle in the yard that's got a lot of green grass around it, I mean, 9 times out of 10 that's probably a septic failure of some sort. Basically that soil, there's some property in that soil that's restrictive to water movement, whether it be platy structure, which we'll cover in another video, or it just could be compaction. It may just be that the soil was compacted to a degree where it will not accept water. You have erosion, shown in this top slide right here, this top picture. Erosion occurs when water is concentrated water movement across the landscape, and it actually moves the soil out of that area. And I mentioned earlier about rivers and streams. We have a lot of erosion in the Piedmont because any given day that river is going to be red. We don't have clear rivers pretty much in the Piedmont after a rain event. There's going to be some sort of red, or that water's going to be red. And trench stability. This is important for anybody doing construction work because you don't want that soil caving in on you, because it could kill you with the weight of it. So you want trench stability is an important thing when you're looking at construction sites. Like plants and animals, soils are classified. So we got a soil taxonomy. That's our system, is soil taxonomy. And through that system, we can group things and other soil scientists can understand across the whole United States what we're talking about. The highest level is the soil order, the lowest level is the series. Some orders that I work around, the soil orders I work around in the Piedmont and in South Carolina every day are alpha soils, ultisols, entisols, and inceptisols. That's the four main ones for us here in South Carolina. And we've already, as you can see, soil science is pretty important, and you can begin to kind of think about, you know, there's more than just walking across it that's going on. You actually can kind of get a feel for the importance of it by just kind of start looking at stuff when you're going around in your day-to-day travels. Just start looking at road cuts, start looking at anytime you see, even fire ant mounds. I use fire ant mounds all the time as an indicator of what type of soil I'm looking at. And we have fire ant mounds everywhere in South Carolina. So if that fire ant is pulling up red clay, you're thinking, he's pulling up red subsoil from somewhere, or is he pulling up gray subsoil? So which you kind of look at and you kind of classify soils based on their color. So just kind of look at the different things and how they're interacting and what they're pulling up, and kind of begin to dig in and, you know, think about the science of it. Think about how soils affected social studies or world trade through the years, and mathematics, history. I mean, it's tied to soils are tied to basically everything. So what I want you to, the main thing is just to kind of dig in, just think about soils as a living organism. And if you got any questions, feel free to call us because we are available. No problem. We'll answer any questions you have about soils. We'd be glad to take you to the field and show you some different things. If you want to see the differences in soils across the area, if we can't explain it to you on the phone, maybe we can show you. So just give us a call.